Day 6. Umbracadabra, Defense Against the Dark Arts of Magic Strings in Umbraco by Joe Glombek. I'm sure many of us have been told at some point in our careers that magic strings are bad. But why exactly is that? And what could go wrong? And what alternatives are there to improve our code? Why are magic strings so bad? We use the phrase magic strings, and to a lesser extent magic numbers, to refer to a constant string used directly in your code. An example of this that we as Umbraco developers may be all too familiar with is model.getPropertyValue. Here, body text is a magic string. The text can be used in multiple places, maybe in the meta tags as well as the page body, or on different templates. Has to be in this exact format. I can't swap it out with "can I have the text for the body please," as polite as that is, and refers to an external entity, the Umbraco database via the Umbraco APIs in this case. These things make it a particularly code-smelly example of a magic string that needs replacing. Magic strings is a term used to cover multiple scenarios of when a string is used in place of a more robust method. Typos are the arch-enemy of magic strings. If we're having a particularly productive Hollywood hacker-style afternoon smacking away at those keys, you'd be excused for mishitting the odd one. They can be particularly difficult to spot too, depending on your font. Body IX could easily go unnoticed. The folks that write our IDEs know this, and will correct us where possible. A string, however, cannot be easily corrected because any value of string is a valid string. As far as the IDE knows, you meant to type Bossy T-Rex. These cause runtime errors rather than the easier to spot compile time issues. Fat-fingeredness aside, magic strings can be exclusive to those who speak a different first language, or people who have difficulty reading and writing. Even if you speak the same language, issues can arise when trying to agree how to spell colour. Or how about a piece of logic that sets this.validation method equals none? We then later decide we need to change the validation method, but it's not obvious what the other possible values are. Magic strings aren't self-documenting, and so we rely on reference documents, or there's a comment that explains how to use it somewhere, or didn't I put that in the README file? This is far from ideal. And if all that wasn't enough, magic strings can make it more difficult to replace a value, test your code, or change logic on your test environments compared to production. We can do better. Is there such a thing as a muggle string? Are there cases where a string is non-magic, or perhaps when a magic string is okay? Yes, not all strings are magic strings, and not all magic strings are necessarily bad. If you're typing a string value in code, the blog Do You Even Code Bro has it boiled down to 4 questions you need to ask yourself. Can you reuse this constant? Can you easily change a few values at once? Does it improve readability? Is it part of configuration? This won't cover all scenarios, but it's a good place to get started if any of your answers to these questions is yes. It's time to look into alternatives. Did you just casually drop the term magic numbers too? I've only just got to grips with magic strings. Ah yes, sorry about that. Yes, magic numbers are the lesser talked about siblings of magic strings, but they can cause the same sorts of issues. Take this code as an example. It's not immediately obvious what this 1.175 is. You might have picked that up that it's the old tax rate in the UK of 17.5%, but it could be easily missed, especially by a non-British developer. Now that we know this is the VAT rate, we also know it's wrong. The UK changed its VAT rate to 20% a few years back. Correcting this value could be difficult too. We need to replace all instances, but if it's written as value equals value plus value times 17.5 divided by 100, someone has gone about code clarity in an odd way. A simple find and replace won't suffice. If, for example, we had a constant of this value somewhere that we reference from everywhere, it would be both clearer what the code was doing and easier to update. Now there are many other tweaks we could make to this code, but I've just solved the one we've been talking about. Models Builder to the rescue. The first example I gave in this article was model.getPropertyValue, which back in the Umbraco 7 days of 2013, Stephen Gay, aka ZPQRTBNK, identified it as a problem and developed the Models Builder package. Models Builder is now a part of Umbraco, and if you're not using it already, you really should be. It removes the need for magic strings when interacting with iPublish content across our Umbraco solutions by generating models for each document type. Dave Wursterberg wrote an article on getting started with Umbraco Models Builder back in 2016, which still holds up well. A constant problem. I mentioned creating a constant just now, and that's probably one of the simplest methods of avoiding magic strings. Depending on the size and complexity of your project, it can be done by pulling your strings up into constant declarations in your class. In .NET, constants, or const declarations, are actually pretty efficient at compile time. They're not allocated any memory like variables are, so it's equivalent performance-wise to directly using the string in each location. It does, however, help us out a lot pre-compilation by removing the magic strings. To make constants reusable across your project, you might find it useful to create a constants.cs file in your project and stick all your relevant strings in there. This can get pretty cluttered on bigger projects, so you may need to categorize your constants further, grouping them into logical classes and namespaces, or adding your constants to related services like so. In fact, with a helper, we could go even further in case we need to apply VAT to other countries in the future. Okay, so in most real-world examples, the country and its respective VAT rate would probably both live in a database somewhere, but it works as an example. A number of other solutions. Constants are great and all, but they can get a little bit repetitive. Enumerated types, that's enums to you and me, are useful for a finite number of constants that won't change. Enums are a great solution to the validation method setting we were talking about earlier. We could create an enum with all the possible values and use this enum in place of our strings. Enums also work well for statuses. Magic numbers and enums. Under the covers, enums actually store integers for each value. In the case of our order status enum, draft is equivalent to 0, paid is 1, pending is 2, etc. You can even explicitly set the number applied to each value, which can be useful if you need to map a readable name to a number, or if you need to add a value to an existing enum, so enums can also provide a valuable solution to magic numbers. JSON and enums. As a side effect of the underlying value being an integer, you might notice that by default, if you return an enum as a JSON result, you'll end up returning the number rather than the pretty enum. JSON and JavaScript 2, without some workarounds, don't support enums, so we have two choices here: return the number or return the string. You've got a few options if you want to convert the enum to and from a string if you'd rather. You can set a converter for individual property with an attribute. Alternatively, set the attribute on the enum definition if you want to be serialized to a string every time you use it. While we're here, you'll notice you can also customize how the enum is rendered as a string with the enum member attribute. Or finally, you can set the behavior globally for all enums by modifying the configure services method in startup.cs. We need to add MVC and Razor to get a hold of the MVC config before adjusting the default JSON options. Your configuration may differ slightly if you're using Umbraco 8 or below with .NET Framework, or if you're using Newtonsoft.json rather than system.text.json in your Umbraco 9/.NET 5 app, but the principles are the same. Flagged enums. Simple enums work fine for things like statuses where only one can be true at any one time, but how about where multiple values make sense? Our validation method example from earlier applies here. It may be possible to have a field that needs validating as required, but also email address. With strings, we could have done this as an array, and we can do the same with enums if we want. But we can also do one better with flagged enums to allow an enum to have multiple values. In this example, we've added the flags attribute to the enum and assigned each enum a value. This bit is important. We can then assign multiple values using the bitwise OR operator or pipe character. It's the same we use two of in an OR statement, this or that. To check if an enum has a flag, we can use the has flag on the enum value. I've had to refactor our switch statement from earlier to use an if statement for each value we want to check for. You might notice the integer I've assigned to each number isn't in order. Well, it is in order, but using a doubling sequence, 1, 2, 4, 8, etc. Each number is double the previous value. This is important because a flagged enum still only stores one integer. It works by using bitwise operations, there's that word again, which simply put is looking at the individual bits, and I mean that in the technical term, of a binary number and applying an OR operation. If any of the bits in that column is 1, it returns a 1, otherwise it returns a 0. For those curious, let's look at the numbers in the doubling sequence in binary. Skip ahead if you don't want to think about binary too much. You'll notice that because they're all powers of 2, each column only ever contains a single 1. Therefore, no matter what combination we make of these in bitwise OR, we can work out which initial enum values went into creating it. In both examples above, to check the value has the flag required, which is 0001, we simply need to check for a 1 in the last column. The has flag method is actually using the bitwise AND flag ampersand under the covers, which does this check. Because of this behavior, we can also add a value for common combinations or all into our enum by adding all the values of the combining values together. Adding and bitwise operations provide the same result in this case because they're all powers of 2, but not normally. Not that an all value makes any sense in this case, but it's good to know. Configure your way out of it. One of the questions we asked at the beginning was, is it part of configuration? This is a good question to ask because it may well change how we deal with it. What is configuration? I like to think of anything that can alter an application's behavior. This value will have been flagged in a specification or by yourself as something that's likely to change, be that in the future or per environment. A URL to an API endpoint is a good example of a configuration variable. It sits outside the control of your application and could conceivably change. Or you may want to point your staging site at a sandbox version of the API. Now we're in the land of .NET 5, we can even get rid of some of the magic strings we have historically used to pull values out of config by mapping whole configuration sections to C# objects. I've also used a constant to get the configuration section name to avoid that as a magic string. Umbracadabra magicless code. Hopefully, I've been able to explain a little about why avoiding these magic strings might be necessary and how we can improve upon them. Don't go crazy, there's no need to replace every variable in your code, but it's worth thinking about in the future for each time you open those double quotes. Happy consting and enuming and model building.